Welcome to a short video on technical electives in the Electrical and Computer Engineering Department at the University of Arizona. And at the very end, we will mention the Accelerated Master's program that you probably need to be thinking about as you are selecting your technical electives if you're interested in pursuing a master's degree beyond your bachelor's degree. And to set the stage for selecting technical electives, you might think about what does your future look like? What are you going to be doing in the next 10 years, 20 years, 30 years? You probably want to make sure that your decisions now are based on the goal or the objective that what you do now will lay a strong foundation for what you can do in the future. And in that sense, I would suggest that you think about selecting your courses, your technical electives, based on a broad mix of different topical areas within electrical and computer engineering. And in front of you here is a diagram that tries to illustrate how our electives and all of our courses, in fact, are somewhat organized. You can see that they're separated into these decades of numbers. You have signals and systems courses that are related to signal processing, communications, and control that follow from courses that you've taken as sophomores and juniors, and maybe even freshmen in those decades. 220 and 320, that's your circuits. 340, that's communications. These are linear signals, linear systems type classes. Those naturally now lead into technical elective coursework that have as their last two digits 20 something, 30 something, or 40 something. For example, ECE 429 would be a digital signal processing class. That's at the senior level, the 400, but it's now in the 20s. And so that's now a 429. 441A, that's a controls class. That's in the 40s decade. Likewise, if you liked classes dealing with electronics, solid state physics, or device physics in the 50s, then electronics courses, you might start looking in that decade of the 50s. You've taken probably 175, 275, 274. Those are computer related classes. The computer classes, obviously, we need quite a few decades to house those, but you're now looking in the 60s and 70s generally in selecting technical elective courses in the 400s and beyond. Electromagnetics in the 80s. And obviously, we've run out of numbers. And so now you will see some courses sprinkled throughout. But if you sort of keep this organization in mind, if you're saying, oh, I want to pick some signals and systems, I want to pick some computer, I want an electromagnetics, now you can start to be understanding where you might be looking numerically at those particular classes. To continue with that thinking, then let's move into what we're anticipating offering for the spring 2022 semester. And they're organized now the way that I will present them in these different groupings: computer classes, electromagnetics and optics, electronics, and signals and systems. In the computer courses, if you've always been interested in how do we figure out how to integrate or differentiate, how do we do that numerically? That's computational techniques that now allows you to understand how to model systems with a computer and to do it in a numerically acceptable or proper way. If you're into machine learning, here's a 523, and you're saying, well, I'm a senior. Well, many seniors have the ability to take 500 level courses. And if you're in the Accelerated Master's program, you can take those 500 level classes towards graduate credit and actually be awarded or use those towards your undergraduate and your graduate degree. That's why you will see 500 level classes and 600 level classes. An undergraduate student can actually take graduate courses either for undergraduate credit or graduate credit. And you can find this now if you simply went to the University of Arizona website and searched on undergraduate enrolled in graduate courses. You'll arrive at this particular page. You'll then see what's required of you to take 500 level or graduate level coursework. You'll need to submit a form to the registrar in order to make that happen. But you can take those courses for undergraduate credit or graduate credit. And if you're interested in the accelerated master's program, you probably want to be considering what 500 level or graduate level classes do I want to pursue as an undergrad, and then I will then have a few more to take to complete my master's degree after completing my bachelor's degree. Continuing on, if you're interested in what's happening in the cloud seems to be involved in many different applications. Fundamentals of Cloud Computing is available in the spring semester. If you liked computer architecture 369A, this is the next class in that sequence. We have a couple of artificial intelligence classes in the spring. We have 479, 579. That's sort of artificial intelligence 1. That's at the bottom of this list or next to the bottom. And then we have another artificial intelligence, or what's called knowledge system engineering. That could be considered AI2, but it really doesn't matter. You can take one or both. The ordering doesn't matter. They're both in the spring semester. And if you want, you could fit both of those in. They are offered at distinct times during the week. And you could have the ability to take a couple of artificial intelligence classes in the spring semester. High performance computing, how do we make these computers perform at a higher and higher level? If you want to know how do we encrypt information, how do we send information secure over a network, that's 471. If you liked 372 and computer architecture, maybe you want to think about embedded system design and optimization. How do we make these small computer devices as efficient as possible? And wireless protocols, how do we now do this over a wireless channel? In the electronics and bio area, if you're a computer engineering track, you can actually take 352, which is required for the electrical engineering students, but device electronics. How do these transistors and diodes actually work at the physical level or at the bottom lower level physics? If you want to design large scale integrated systems for digital applications, now you're looking at 407, 507. Again, if you're in the computer engineering track, you have both of the foundational electrical engineering courses available in the spring. Electromagnetics, how do we actually transmit information through this air and have these electromagnetic waves propagating? That's what you will start to understand and become comfortable with. And that actually relies on some of your calculus, your vector calculus understanding. And so now you can see some applications of that. We also have courses that are ECE courses, but they may be taught by optics faculty or faculty from other departments. 403 is one of those, mathematical methods for optics and photonics, if you wanted to get into the mathematics behind optical systems. If you wanted to know about solar energy, that's 414A for photovoltaic. How do we optimize these photovoltaic systems? Another interesting connection with optics and electronics is advanced topics in optical and electronic materials. How do these optical, or what are the optical properties of these different materials, and how do we build optical and electronic systems out of these materials. There's a photonics communications lab. If you're interested in electromagnetics, then antenna theory. We have a lot of antennas now floating around because of all of these wireless devices. How do those actually work? You'll learn that in 484, and that should be 584 as a number. If you wanted to know how do we do this at the microwave level in terms of circuit design, now in the spring semester, this class actually requires, I'm guessing, 486 to really step into the 488 version. This is a 2-semester sequence. This is now active circuit design, which follows passive circuit design, which is 486. So if you want to know waveguides, etc., maybe you want to start in 486 next fall and then move into this particular class if it's offered next spring, in spring of 2023. The last category is then in the signals and systems area, and these follow up from 220, 320, 340A, those foundational classes, software defined radio. How do you now build radios and change them up in software? Now we have a lot of flexibility with design. Now, how do we make that happen in a radio environment? Digital image processing, that obviously is a follow-up to 429, but if you've taken 429 or 529 in the fall semester, you can now move into digital image processing. If you've taken 340A, now you can take digital communication systems, 435A. Digital control systems, 442, if you wanted to know how do we control devices with embedded computers or bigger computers or some kind of FPGA device, you can now learn about the theory of that in 442. And 442 and 441A, which is a fall class, are not necessarily required, but they complement each other very well. I don't say they're not necessarily required, meaning they're not prerequisites one for the other, but if you've had one, you'll more easily grasp the material in the other. But logically, it might make more sense to have taken the analog control class in the fall, which is 441A, and then follow it up with the digital. But if that's now out of your sequence, it's fine. It's now designed to take 442 without having had 441A. Now, here are some PhD level courses. Information theory is 636. Quantum information processing and error correction is at 633. And detection and estimation, that's 639. Those are in the communications area and obviously in quantum. As you're planning your semester of courses in the spring, you could look at this chart to try to understand if you now need to select between one or two options. For example, you won't be able to take this numerical methods class, ECE 330B, on a Tuesday, Thursday, and also take ECE 352. They overlap or they're taught at the same time. So this now tells you or shows you how to possibly select your classes. And I wouldn't necessarily select your classes based on convenience of time, but what will work with your schedule and what material do you really want to start learning now to build a strong foundation to pursue your career for 20 or 30 years. Then quickly, we have similar planned courses in the fall semester. And as you're planning your technical elective coursework, I would suggest that you plan more than one semester into the future, because a lot of these are sequential. If you're an electrical engineer, you can now take the foundational classes 369A, computer architecture, and 373, object-oriented software design, for your technical elective courses. If you want to know how systems are modeled in physics or biological systems, that's 411, 511, Internet of Things and web development, design, modeling, and simulation, DMS of high-tech systems in medicine. How do you actually build something that might be used in a medical environment in terms of a computer-based system? If you like 274A, you might enjoy then the senior level version of that, 474A, computer-aided logic design. How do computers talk to each other? How do we build these computer networks? Cybersecurity, concepts theory. How do we deal with secure cyber systems and distributed computing systems? What if we do have computers distributed, and we have all of these now wireless devices. Everything seems to have a computer in it. How do we communicate? How do we distribute that computational load? Now we're computing at the edge, meaning right at the edge of the cloud. How do we make that happen? Relative to the biomedical or the electronics area, we have, again, electrical and optical properties of material at 434. Maybe we'll have a 450, 550 analog integrated circuits. And how do you now build these or manufacture these devices? As I said earlier, the microwave engineering 2 was 488. Here's the beginning semester in that sequence. Microwave engineering 1, that's passive circuits. How do we think about optics from an electrical engineering perspective? Now you can start communicating with optical engineers and people familiar with the physics of optics after having taken 459, 559 holography. If you've always been interested in optics area, or the step up from 381A, you have 581A. And again, here are some courses in the signals and systems area: signal processing digitally, automatic control, advanced linear system theory, and then you have these 500 level classes: probability and random processes, digital image analysis. We do allow you to take technical electives outside of electrical and computer engineering, a limited number. You could actually take 2 of those if you're now planning to maybe pursue an entrepreneurship type experience. You can do that, but I would suggest you do that in your junior year if you're in electrical and computer engineering, or if you're in engineering, because the times on these 2 semester sequences for the McGuire program actually conflict with the capstone sequence ENGR 498A/B that is held in the College of Engineering, and you need to take that in your senior year. Now you can take these McGuire entrepreneurship sequence of courses in your junior year, fall and spring, and now you have a very nice package in terms of, what if I do want to be more entrepreneurial and start my own business? Now you have the skills that you would acquire in that program. And here is a very tentative schedule of what you might find in the fall semester in terms of courses, when they're offered, time of day, and which ones are offered at the same time, so you will be unable to take both of those in a fall semester. I mentioned briefly the Accelerated Master's Program. If you have a 3.3 cumulative GPA, and if you now are beyond 75 units, which is basically halfway through your junior year, you can apply for the Accelerated Master's Program. What this allows you to do is to take graduate level courses and count up to 4 of those towards both your undergraduate bachelor's degree and your master's degree. If you do a coursework only master's degree, that corresponds to 10 3-unit courses. If you've now been able to complete 4 of those as an undergraduate student and count those towards both your undergraduate degree and your graduate degree, now you only have 6 courses remaining to complete to finish up your master's degree. And that's why we call it accelerated, because now immediately after finishing your bachelor's degree, you're able to step right in and quickly complete your master's degree after having taken up to 4 of those courses in your senior year. You can then enroll in those courses after reaching your senior year, which is when you have now 90 plus units. And many of our students have many units because they come in with more than 0 units to begin with. But that's now a really nice program for you to consider if you meet these requirements. You also are no longer required to take the graduate record exam. We waive the GRE requirement if you get into the accelerated master's program. If you're interested in that program, you should contact our advisor for the graduate students, Tammy Whalen, and here is her email address to establish communication with Ms. Whalen. I talked a little bit about enrolling into graduate courses at the undergraduate level, and you can do that even if you are not in the AMP, but obviously you have to have certain minimum requirements, and that is you need to have a minimum cumulative GPA of 3.0. You need to have the approval of the course instructor and the student's major advisor, and you'll need to have final approval from the Office of the Registrar, which is why you're submitting this form. You could also take it for graduate credit. If you had plenty of undergraduate credit, that's possible. But you can now also find more descriptions of these courses by going to the catalog on the U of A website. And in fact, you could get there if you simply were at, well, maybe I should go back to the University of Arizona website. If you're here at the homepage, you could go to academics, class registration. Now you can go down to course descriptions. Now you're at the catalog page. You can click on courses and now go to the course catalog. It will open up. You can type E to get you a little closer to electrical and computer engineering. And now if you want to see all of the courses, short descriptions, you can click on this and it will generate a PDF file of the various courses that are listed here. If you wanted to just see some of those courses by themselves, you could simply click on one of these links and it will take you now to that description, and you could view when the class meets, etc. If you wanted to find out a little bit about each of the classes in terms of their learning outcomes, you could go to our web pages on the ECE website and click on, now if you were interested in digital signal processing, now you have a web-based syllabus. Here are the learning outcomes for that class, and that gives you a pretty clear picture of what you're stepping into for each of those particular classes. And you can do that at the graduate level. If you go to the graduate program and courses, that's now available to you for some of these graduate level classes. Finally, I should mention that if you're interested in understanding a little bit more about the research interests, what the faculty have done or are pursuing research-wise, you can check out their videos on our website as well. And I've tried to include that information in terms of these links at the bottom of these notes. So here are the links to the short versions of the syllabi for the undergraduate classes, the graduate classes, and the faculty videos. Here's how to find the ECE course descriptions, differing a little bit from the syllabi, but here is the sequence of pages to follow to get you to that location. And finally, here's the link to taking graduate classes as an undergraduate student. I hope that that was beneficial. Remember, you want to be thinking broadly in terms of your technical electives so that when you do complete your undergraduate degree program, you're now well prepared to step into many different areas of opportunities in the technical field associated with electrical and computer engineering. Good luck with your selections.